So RAID is a really interesting concept because it's used quite a lot in a lot of network systems in order for data security, speed, and just making sure that your data is actually safe in terms of if it's damaged. So obviously security and damage are two separate things because they could be damaged and you'd lose something, but obviously you don't want people to steal it either. So there is two types of safe. There's security safe and obviously just making sure the data is actually safe itself. Um, so RAID is called redundant array of independent disks. Essentially, a redundant array means that there is more than what is needed. So there is a bunch of hard drives because that's what RAID is. It's for storing data onto multiple hard drives. So when it says redundant, there is more than enough hard drives that's needed. Redundant means that you've got too many. You don't need that many, but the reason you do it is because either you need to store more data than you need, or you need to make sure the data's secure or quick, or performance-wise, it's faster than I said earlier. Um, so independent disks would look something similar to this. So as you can see on here, there are multiple different hard drives lined up, and obviously there's racks and racks of it. Now, if we take a closer look, they're all numbered. Now, usually, what will happen, you'll have a RAID array where you'll have different hard drives across it. Depending on how you got RAID set up, it might be that the exact same data is stored across all of them. Um, and I will go over what that means in more detail in a second. So, essentially, all you need to remember is RAID is a number of different hard drives that work together in order to perform a specific function. Depends on what you set up that specific function for. So obviously it can be used in a standalone computer. So you could just set it up in your computer at home if you really wanted to. Like that's only if you're wanting to save data for any particular reason. Um, Obviously in a network system, it's used more often because you don't want to lose data in a network system, or it might be that you need data to be accessed quicker or saved quicker in a network system, because obviously a lot of places push for the network to be faster than um, actually go for making sure data's safe or what have you. It depends on what you need it for, essentially, is what I'm saying. Um, it does all depend on stuff like that. So let's have a look. So obviously, you can use SSDs or you can use hard drives. Normally, hard drives are used because they are more resilient than SSDs. SSDs can be damaged quite easily depending on what you're doing with them, whereas HDDs tend to be um, more robust. So if you ever need to use uh, SSDs in a RAID, you can. It'll be a lot faster, but they will not last as long as hard drives will. Hard drives last a lot longer than SSDs in that respect. So that's something that you've got to be aware of, because that can be a major issue. Um, Also with RAID, so like I said before, data security, data redundancy, and improving speed. Again, I'm just putting that on there because obviously if you read it separate, you can see it, but I've already gone over that multiple times now. So RAID standards. Now, this might look really scary because there's RAID 0 through to 6, and there's numerous different things you can do with it. So this table basically just explains that there's essentially 7 types of RAID, because obviously 0 counts as one. There's 7 types of RAID you can use. So if we look at RAID 0, what this says is that um, you can write across every single drive, so making it fast. Tolerance is essentially how many drives can fail before the system goes down. Now, as you can see for RAID 0, the tolerance is none, which means that if one of the hard drives fails, then all of them will fail. And the minimum number of drives you can have is 2. So obviously you'd need at least 2 drives to set this RAID up. Obviously it can go up to a maximum number of whatever you want. There is no limit on how many things you can have. So just to make this a little bit clearer, if we were to look at RAID 0, which is writing across all of them. So, whoops, I can't seem to get my pen working. Just give me 2 seconds. We should be okay. There we go, pen's working now. So, with RAID 0, you've got a number of disks, usually all connected together in a line like this, just so you can see them all. And with RAID 0, it basically says, right, as soon as, say, like, I don't know, say, like, you're making a video, when it saves it, it will save it to every single drive across it, essentially. So it's like the video might take up 3 hard drives, say, because all these act as one big hard drive. So all of them is like having one huge hard drive. So say they're all, say they're 5 GB each. Oops, I need to make a uppercase G, but you understand the concept. So 5, so that would be 25 GB altogether. But obviously they're all separate within it, so they'll all be separate. So literally that's all that is. It's just that they're all separate entities. It's not that it's it's locked into that. That's only RAID 0, so this is literally just for RAID 0. Now, obviously there's problems with this because say this hard drive dies, it will take the rest of them out with it, so all of these will also die with it. So RAID 0 is good if you want something quick and easy that you just want a big hard drive for, but if anything dies, then you've got a big issue. So it's not the most ideal thing in the world to use, unfortunately. So it's not the best. But a lot of places do still use it. Just if you want something quick, it's usually used for things at home. So if you want to set it up at home, that would be absolutely fine as well. But if we look at RAID 1, I'm not going to go over them in too much detail because they're all quite self-explanatory. 1 is probably one of the most commonly used ones. So on that one, if you look at the tolerance, all but one drive can fail. So if one drive fails, it will carry on. If another drive fails, it will carry on. If all drive fails, well, they've all failed. So yeah, of course it's not going to work. If we quickly look again on my drawing canvas, so with the way this sort of works, you've got, again, hard drive set up in a space. If you do say something like a video this time, instead of it being shared across, say, 3 of them like it was before, so 3 of them like that, what it will now do instead, let's get rid of that just really quickly, it will save itself onto each of these, so it'll go onto that one, onto that one, onto that one, onto that one, onto that one. So there'll be literally just a video on each drive. So it's quite useful because if one of the drives fails at all, so say like this one dies, it'll just carry on and you've still got all the data backed up. So essentially it's really good for backup. The only issue with this is you can only have a maximum capacity of your smallest hard drive. So it might be that this one, say, is a gig large, and then say this one is 5 GB. I need to put gigabytes in better terms than just this lowercase g. Do not put lowercase g. It needs to be uppercase g like that. That's my fault. But say that's 5 gigabytes, that's 1 gigabyte. The maximum you can store is just 1 gigabyte because you can't. If you try and upload a 5 gigabyte file, it cannot be shared across all of these. So you cannot put them across every single one because you're limited to what your smallest hard drive is. So you can use different hard drives that are different sizes, but you're limited to what the smallest one is. So that's the only problem with RAID 0 is RAID 1, not RAID 0. So this is RAID 1. So the problem with RAID 1 is that you're limited to the smallest size, which in this case is 1 gigabyte. It's pretty straightforward in that sort of sense. So with RAIDs 2 through to 6, um, all the tolerance on them is one hard drive failure. Well, apart from 6, which is 2, but one hard drive failure means if one goes, the rest of them will not work. So that's why RAID 1's one of the most used one, because it mirrors everything that you copy across. So it's very good for sort of keeping your data safe in terms of, have it being lost. With 2 through to 5, essentially they use something called error code correction or parity error code correction. Now, these things that are cropping up saying parity error correction and stuff like that, all that is that it will use a bit in order to just check that every RAID device is getting the right amount of data. So RAID 2 through to RAID 5 is the same as RAID 0 in terms of it uses all the drives together to make one big hard drive. But with 2 through to 5, they actually check that things aren't going wrong, whereas RAID 0 will not check. So if a piece of data is not saved properly, it won't have saved properly at all. Whereas RAID 2 to 5 will check. So when it talks about stuff like striping or stripping, some people call it striping, I call it striping usually. It's basically to improve speed. So when it's talking about striping, it's supposed to be essentially making stripes of data across all the drives. So it might be that they're split up into blocks, just to sort of help make that understandable a bit easier. So when we're talking about striping, I'll find my eraser, there it is. So striping is essentially, you got your hard drives again, all set up in RAID. So say it's RAID 2. It might be that when you're storing your video again, you split it up into small chunks. And you put one chunk on the first one chunk on the second one, and one chunk on the third one. So you basically split it up and put it onto different hard drives. Now that's fine, like that sort of system works perfectly, but obviously that also means that if one of these hard drives fail, you lose essentially your third block, so that there can be a major problem. But that's where parity error correction comes in, and basically what it'll do is it'll take each of these, so say these are the data blocks for your video, it will basically do checks for each of them every time something goes in, and if they're fine, it then puts them onto the hard drive. If something isn't right, it will basically go, all these cannot be uploaded. So if something goes wrong, it will let you know and basically not put it on, because there's no point putting corrupt data onto your RAID system because you can't use it. So it knows that, and it will stop you from doing that. I know this is a lot of information being thrown at you for RAID. What I'd suggest you do is research this, and we'll probably be doing some revision on this as well anyway. But have a look at the book as well if Paul has showed you the book, but um, the book for computer fundamentals of computer systems is really really good. Um, so the book that you're probably looking for, I'm trying to find it online, but I can't find it. But essentially, it's the BTEC National Computing book. Like they write everything on this, and that's where this table is from. I would recommend you use it to sort of look up this sort of stuff. And there's a revision book as well, which will also help a lot. But RAID is not an easy concept to grasp, really. Um, it's very complex to set up. In terms of theory behind it, it's quite straightforward, but setting it up is a lot more difficult than what you would think it would be. But if anybody's got any questions about it, please let me know, because obviously this is not an easy topic to grasp. It's RAID is something that you probably will have to set up at some point. I'm probably going to try and get us all to set it up so you can sort of see what I mean about it being set up. But please have a look at this. I will go over it in class as well, just to make sure that everybody understands how this works. But please let me know if you've got any trouble with it. But it should be fairly straightforward as a concept.